Hi there, my name is Neil Blevins, and this tutorial is called Material Properties for both 2D and 3D artists. So whether you're a 2D artist using traditional or digital painting, or a 3D artist using rendering algorithms, replicating materials comes down to a deep knowledge of what specific materials look like and why they look that way. So here's a collection of information about real-world materials, why they look the way they do, and what attributes they have that you will need to replicate, regardless of whether you're using 2D or 3D tools. So most standard materials fall into one of two categories. You have metals, which are also known as conductives, or nonmetals, which are also known as dielectrics. And we'll get into much more detail about this a little bit later. So in those categories, most materials also potentially reflect or transmit light in 5 different ways. You have diffuse reflections, specular reflections, transparency, translucency or subsurface, and emission. And most materials reflect or transmit several of these at the same time. So here you can see just 5 quick little shader balls from a 3D program showing the 5 different kinds of reflected light from materials. So we'll start with diffuse reflections. So these are a couple of very diffuse materials, basically bricks or a concrete stucco kind of stuff on the side of a school. And you can see it reflects light pretty evenly, and that's one of the main things about a diffuse reflection. And here's an example of specular reflections. So you can see there is a diffuse component here, which is, for example, the color blue over on the left. But then you can also see the strong reflective highlight that's on that surface. And you can really see the reflective highlight on the metal surface, which is over on the right. So that's called a specular reflection. Then there's transparency, which is anything that you can see through. So one of the best examples of that would be glass. Then there's translucency, which also lets you see through, but instead of seeing things directly through, you're actually seeing just the light coming through something. So examples would be, for example, candles or grapes or various fruit, where if you put a light behind it, you can see the light coming through the surface. And then finally emission. And emission is not actually a reflected light, it is light coming from the actual object itself. So that would be like glow-in-the-dark paint, or on the image on the right, certain kinds of algae actually have this property. And then here's 5 diagrams showing the difference. So you have the diffuse reflection, which the light hits the surface and bounces out kind of evenly. You have a specular reflection, which is far more directional. You have transparency, where the light hits the surface, goes through and gets bent, and then comes out the other side. You have translucency, which is that the light goes into the surface, but then bounces off things inside of the surface and bounces either deeper in or bounces directly out, causing that sort of subsurface look. And then finally emission, where there is no light hitting the surface, and it's instead emitting from the surface itself out in all directions. So now we need to speak really briefly about energy conservation. And this is the property that your object can't reflect more light than it receives. So if a surface is hit by a light value of 1, the diffuse, specular, subsurface, and refractive components of the material must be equal to or below 1. So let's just do a simple version of this. So we have our light source, which you can see over on the right, and it shoots an energy value of 1 and hits a surface. And that surface has those different surface properties that we just discussed. And for example, if your specular reflection is 0.25, then the diffuse reflection can't be any larger than 0.75 in order to keep that energy conservation rule active when it goes to your eye. And this is a thing, so you can see here, because diffuse plus specular must equal 1. If diffuse is 0.75, then specular is 0.25. If diffuse is 0.3, then specular would be at most 0.7. And it's the whole idea of keeping that ratio together. So it means that if a surface is more diffuse, there's less specular. If it's more specular, there's less diffuse. And again, this is just a simple example showing only 2 components, but all 4 of them, the main ones, must follow this rule. So if you have some subsurface in there, it means that the diffuse and the specular has to go down a little bit as well in order to achieve that 1.0 balance. And just to mention, emission is not part of the energy conservation calculation because emission is emitted light. It's not light that's bouncing off the surface when it gets hit. So now let's talk a little bit about specular reflections. So when you see something like, for example, over on the left here, and you see these highlights that look kind of, long or round, what you're actually seeing are reflections of the light source. So if we zoom in, we can see that that little spot down there is actually these two long cylinders of light, and that is reflecting from the light that is above the surface. And then also there's the law of Fresnel and IOR. So surfaces reflect more light at glancing angles. So you can see here on the left, if I'm looking directly at a piece of glass and taking a photograph, I can see my reflection. But then if I instead go at a glancing angle on the same window, you can see that the reflection is much stronger as it goes off towards the edge instead of looking at something straight on. And this is called Fresnel. And all sorts of different objects have Fresnel. It's not just glass or metals. Pretty much everything has some sort of Fresnel value to it. And you can see that here. Like you might think that this leaf, if you look at it straight on, is not very specular. But then when you look at it at a glancing angle, it actually becomes very specular, as you can see up in the top there. Even something like this. So this is a piece of cardboard, which is something you don't really think of as being terribly specular. But if you start rotating it around at a glancing angle, you can see that there's a reflection of the sun in the surface. So the amount of Fresnel is controlled by an object's IOR value, and larger IORs mean more reflectivity on the front surface. So for example, here's a shader ball with an IOR of 1.2, where you can barely see the reflection on the front. And then the next one is an IOR of 5, where you can see the reflection on the front surface a lot stronger. And metals tend to have higher IORs, and non-metals tend to have lower IORs. Then we need to speak about the roughness of the surface, because the rougher a surface is, the blurrier the reflection is. So you can see here on the left is chrome, which is very, very smooth, and so you have almost a perfect reflection of whatever is above it. And then you can see on the right, here is a surface of a brushed metal fridge, and you can see that the reflection is quite blurry. And here's another example. So these are plastic egg containers, and you can see here there's a very obvious reflection of the sun. But then I took one of those and I took some sandpaper to it, and taking sandpaper to it made it very rough. And so you can see it's reflecting the same stuff, except now the reflection is much, much blurrier of the sun than on the one that's on the left, which is the one that I kept the same as before. Now also when it comes to reflections, there's something called anisotropic reflections, and that's any reflection that's stretched due to grooves in a surface. So if it's random like this, you'll get a blurry reflection that kind of blurs in all directions. But if your bumps, the tiny bumps on your surface, have a directionality to them, we get a different effect. And here's some examples of that. So what you end up getting is, instead of a simple blurry reflection of something, the blur is actually stretched in a particular direction, depending on the direction of the grooves. And you get stuff like brushed metal, like at the bottom of a pot, or this photograph from the airport. And what's happening here is, technically each groove is getting a little tiny bit of reflection from whatever is reflecting in it. So for example, here you can see we have a light source in a bathroom, and then it's hitting the little door stopper at the bottom. And you can see how instead of just being a single reflection on one of these little grooves, each groove has a reflection. And what that does is that stretches it out. So a little bit behind how the anisotropic reflection works. And here's some more examples of the same thing. So you have threads on this Christmas ornament that are stretching things. Or cars and their headlights are being stretched because of all the distortion that's happening in the rain on the puddles. And something similar in that middle lower image, where you can see that the different sets of puddles are pulling the reflection of those traffic cones to make them a lot longer than they actually are in real life. So we talked a lot about little tiny bumps, but also larger bumps, which I usually refer to as warbles, that can also cause distortions in a reflection. So you can see that here, for example, in the side of the truck that's reflecting the bridge, or the pole of the lamp, which is in the reflection on the glass surface here. So I promised we'd get back to the difference between metals and nonmetals. And one of the main differences is that nonmetals tend to be more diffuse, and their specular reflections aren't as tinted by the surface color. Whereas metals tend to be almost exclusively specular reflection, and their specular reflections are heavily tinted by the surface color. And this is a pretty good example of this, or perhaps even a better example. Take a look at this surface. So this is all specular reflection, or mostly specular reflection. And you can't even tell what color the stuff is in the room, because it's all being tinted very, very strongly by the surface color, which is this gold color of this particular metal vase. We also talked a lot about how bumps can affect specular reflections, but it also can affect the diffuse as well, which you can see here. These are larger or smaller bumps on a surface, and that creates these little tiny shadows, and those little tiny shadows is what allows us to see the bump on the surface itself. So finally, let's talk about overcoats or layers. And this is two or more layers of materials that sit on top of each other. And each material by itself might have a different set of surface properties, but combined it produces something entirely different altogether. So a couple of examples. A flat diffuse wood has a clear coat of shellac painted on top. So now you have a highly reflective surface in terms of specular reflection, but you can see the original wood underneath. Another example would be a metal surface that's covered in dirt. So the metal might be very, very specular, but the dirt might be entirely diffuse. And also a wet rock. So the water on the surface produces a powerful specular reflection, even though the rock is very diffuse. So here's an example of a specular overcoat. So you can see here that this is regular wood on a chair, but then somebody went and painted shellac on it, which gives it that really, really strong specular highlight. And then let's talk about the dirt example, which is weathering. And weathering is interesting because it is both two different materials that sit on top of each other, or at least two different materials. But on top of that, there's all sorts of fascinating patterns that's caused by the weathering itself. So some examples, I usually take weathering and split it into 6 different categories. And the categories are dirt, dust, patina, rust, staining, and wear. And then these categories also have different patterns that happen in them. For example, things that are dripping, stuff around the edge, scratches, smudges, spills, splashes, splats, and spots. So just going through them really briefly, here's some examples of dirt. And so there's some dirt dripping, dirt around the edges because it gets caught in there and can't be cleaned out, and then smudges that can happen. Then there's splashes of dirt, like for example, a car that is going through a bunch of dirt as it's driving around. And there's an example of spots. And then dust, usually dust is on tops of surfaces, so it tends to collect on the top and not on the sides. And also you have dust that gets caught in the edges of things. Then patina is an example of a reaction that happens usually on metals. So if you have something that's copper, you can get, for example, that green patina that happens at the edges of things. Then rust, once again, you can have drips, you can have rust around the edges of stuff, you can have scratches and spots. And then staining, you can have, again, the drips, staining around the edges, spills, splats, and wet paint, where the paint sort of smudges. And then finally wear. So for example, edge wear, where little bits chip around the edges of surfaces, more scratchy sorts of wear, and then spots. So when working in 3D, many of these properties are broken out into parameters you can adjust their value or add bitmaps to control them. But even when painting in 2D, I tend to split these properties out. For example, have a layer in Photoshop for the diffuse, a layer for the specular, a layer for translucency, or a layer or multiple layers for weathering. And that allows me to control each one separately, which I feel allows me to get a more realistic result. And then here's just a few examples. So this is weathering in 2D, which I painted digitally in Photoshop. And you can see how all these different layers, you have the spots, you have the scratches, you have edge wear in different spots, and those will all be on separate 2D layers. And then here is weathering in 3D, traditional, so this is an actual model that I painted. And you can see adding the weathering there, where you have dirt, you have dirt over the surfaces, spots over the surfaces, and then also dirt at the edges of things. And then here's an example of weathering in 3D as well, but this one is digital. And you see the same sort of thing. You can see wear happening at the edges. You can see spots of dirt in various areas. And so really it's all the same thing. It's just depending on which medium you're trying to show off the exact same material properties. So here's all the material properties in one handy chart. So you have the diffuse component and the specularity. And the specularity is dependent on the Fresnel of the surface. And also the roughness of the surface, which can be smooth, uniform bump, or an anisotropic. You also have to think about whether it's metal or non-metal, because that affects the look of the specularity a lot. Then if the surface is transparent at all, is it translucent or has any subsurface to it? And then also whether it's emissive. Then you need to think about the larger bump and how that affects not just the specularity, but also the diffuse. And then layering and overcoats. So usually those falling into the categories of specular or weathering. And so one thing that I do with students who I give this talk to is I actually have them go and find 5 different interesting looking materials and then have them break up those materials based on these different properties. So, how diffuse is it? How specular is it? What kind of bump that it has? So anytime I'm in either 3D or 2D, I always think about these different properties, and I try to emulate them by looking really, really carefully at the reference and then breaking it up into these different parts. And when I do that, I tend to find that my materials look far more realistic. And then one final note, this particular lesson is kind of a summary of a much more detailed set of topics. And so if you're interested in learning more and getting into more details, feel free to go to neilblevins.com and go to the education section. And then if you go down here in the menu, down to shading and shader theory, you can see there's a lot more information here about energy conservation, diffuse reflections, specular reflections, anisotropic reflections in the real world and how they work, transparency, translucency, with lots of different examples. And so this is all the same material that I just went through, but in much more detail. So feel free to check it out if you have more questions about any of these topics. So thank you very much for watching. I hope you found this interesting. And if you want to be notified the next time I post a new video, please subscribe to my YouTube channel. Thank you very much.